Let's go over the review for the first test of the third 6 weeks. I'm going to start with number 2. Okay, so I'm just going to follow along with note card 42. The first step says to factor the top and the bottom if possible. And so it is, and so I'm going to begin factoring. The top is a GCF. So I would pull out a 3, and I'm left with x squared minus 4, which is also the difference of squares, but let me just start and go from here. This part down here is Mustang factoring. I'm looking for two numbers that add to 4 and multiply to negative 12. That's going to be an x plus 6 and x minus 2. Not quite finished yet. I can factor this. This is the difference of squares inside parentheses on top. So that's going to be 3 times x plus 2, x minus 2, over x plus 6, x minus 2. So it's completely factored. The next thing, step 1, factor. The next thing we're talking about is if it has factors that cancels, and this does. The x minus 2 factors cancel out. And so my next step says that if something cancels, I have wholes. Okay? And so I have a whole at the factor x minus 2. Now that whole, this whole, has an xy value. It's an xy value. Okay, so you have to find the x and you have to find the y. Well, you find the x by setting this factor equal to 0 and solving for x, and you get the x is equal to 2. And so the x value of my whole is 2. Now I need to find the y value of my whole. The way I find the y value of my whole is I go back to what was left after things canceled, and what's left is y equals 3 times x plus 2 over x plus 6. So I go back to what I had left, and then I plug in that x value and solve for y. So I have y equals 3 times x plus 2, but x is 2, so it's 2 plus 2. See, x is 2 right here. I'm plugging in a 2 for x. Over 2 plus 6, which simplifies to 3 times 4 over 8, which simplifies to 12 over 8, which reduces to 3 halves. Because 12 and 8 have a common factor of 4. 12 divided by 4 is 3. 8 divided by 4 is 2. So the y value of my whole is 3 halves, or 1.5. Remember, you're not going to have a calculator on this test tomorrow. So I have a whole right here. There's my whole. Moving on, the next step says to find the X-Intercept. To find the X-Intercept, I suppose I could fill this in. My whole is at 2, 3 halves. And that's all I know so far. To find the X-Intercept, I set the numerator equal to 0. The numerator of what was left, okay? What was left is this, 3 times x plus 2, and I set it equal to 0. There's two ways to solve this equation here. Probably the easiest way for everybody is to go ahead and distribute this 3, and you get 3x plus 6 equals 0. Subtract 6. 3x equals negative 6 divided by 3, and this cancels and you get x is equal to negative 2. My x-intercept is negative 2. Next, I'm going to find the y-intercept. To find the y-intercept, I take the part of the function of what was left. Again, it's y equals 3 times x plus 2 over x plus 6. To find the y-intercept, you substitute 0 in for x. So I have y equals 3 times 0 plus 2 over 0 plus 6. You should know by now that the y value of the x-intercept is 0. So that's why we plug in this 0. Okay? So I simplify, and I get 3 times 2 over 6, which is 6 over 6, which is 1. So the y-intercept is 1. Now, continuing on, to find the vertical asymptote. To find the vertical asymptote, you set the denominator equal to 0 and solve for x. Of what was left, remember, we're talking about what's left here. We're working with this thing right here. So I take the denominator, set it equal to 0, and solve for x, and I get that x is equal to negative 6. My vertical asymptote is the vertical line x equals negative 6. Now to find the horizontal asymptote. To find the horizontal asymptote, we have to find what A, N, B, and D are. Remember, A is a number in front of x on top. N is power of x on top. B is a number in front of x on bottom. And D is the power of x on bottom. So what are these things? If A is a number in front of x on bottom, on top rather, that's 3. If N is the power of x on top, that's 1. If B is a number in front of x on bottom, that's 1. And if D is the power of x on bottom, that's 1. If you examine note card 42, it tells you that if N is equal to D, which it is, N is 1, D is 1, then your horizontal asymptote is y equals A over B, which is 3 over 1, which is 3. So my horizontal asymptote is the line y equals 3. And now I'm ready to graph it. So I start by graphing. I've got a hole at 2 comma 3 over 2, or in other words 2 comma 1.5. So it's 2 comma 1.5. That's me right here. I have a hole right there. My x-intercept is negative 2. That's where it's going to cross the x-axis. I'm going to plot it. My y-intercept is 1. That's where it's going to cross the y-axis. I plot it. And now look at my asymptotes. I have a vertical asymptote at negative 6. Plot it. I have a horizontal asymptote at y equals 3. Plot it. It's going right through the y-axis on the 3. Now I'm ready to try to graph it. And this bottom portion right here should be easy because we know it's going to go right through from the hole, right through the y-intercept, right through the x-intercept, never going to touch this vertical asymptote. It's going to go that way. And so if it does that, the functions typically do not cross the horizontal asymptote, so I'm going to think, because I've been doing all my homework, it probably looks like that too, and it's never going to touch that. And then also because I've been doing my homework and checking my graphs in my calculator, I've been noticing something. These rational functions most of them have been having some type of symmetry from let's say if you have two asymptotes, a vertical and a horizontal, you have basically 4 quadrants. You have this quadrant, this quadrant, this quadrant, and this quadrant, separated by these 2 lines. And we've been having symmetry, what I would call like a diagonal symmetry. Like if I could draw an imaginary line right through here, they've been having this symmetry in this line where if this piece is down here in this quadrant, this other piece is going to be up there. And that's what my graph looks like. And I would check that in my calculator and I would see that I'm correct, and I would move on to the next problem. Okay, let's look at number 3. Again, running through all of the steps of note card 42. Factor the top and the bottom if possible. It's factorable, and I'm going to start right here. I've got, this is a difference of squares, so I have y equals x plus 3, x minus 3 over x plus 2. But on this one, nothing cancels, so I have no holes. Nothing cancels, I have no holes. Move on to the step where I'm finding the x-intercept. To find the x-intercept, we set the numerator equal to 0 and solve for x. So I have x plus 3 times x minus 3 equals 0. And it's okay to have 2 x-intercepts, so I set each factor equal to 0. A lot of you have been having a hard time with this, but we know how to do this. This is solving a quadratic. You set each, after you factor it to solve the quadratic, you set each factor equal to 0. So here you get x is equal to plus and minus 3. So my x-intercepts, I have 2 of them at plus and minus 3. Now find the y-intercept. To find the y-intercept, you plug in a 0 and solve for y. Now, since nothing canceled, you could use the original or you can use this one. It doesn't matter. I'll just go with someone said it confused them to go back to the original, so I'll do this one. So I have y equals 0 plus 3, 0 minus 3, over 0 plus 2, which gives me 3 times negative 3 over 2. Now, some people were wanting to add these together. You got to remember that this piece is being multiplied with this piece. So you simplify inside the parentheses first using the order of operations, and then multiply. This reduces or simplifies to negative 9 over 2. So my y-intercept is negative 9 halves. And since we have no calculator, I hope you don't struggle too much with recognizing that this is nothing else but negative 4.5. And it will help you to know that by graphing it. Another thing you could do is remember this. Simplifying here, 2 goes into 9 4 times. With 1 left over, 2. And it's negative. Negative 4.5. Negative 9 halves, negative 4.5. All the same number. These two will be easier for you to plot that point. Alright, so we got our y-intercept, our x-intercept, no holes. Vertical asymptote, I take the denominator, set it equal to 0, solve for x. X equals negative 2. So my vertical asymptote is x is equal to negative 2. Simple stuff. Horizontal asymptote. Here's where I find A, N, B, and D. A is the number of x in front of x on top. I'm going to go back to the original. Since nothing canceled, it's going to be easier for me to see that N is 2 in this case, since nothing canceled. Okay, A is 1, N is 2, B is 1, and D is 1. So I need to look at my note card where it tells me how do I choose. In this case, N is greater than D. So this tells me something about my horizontal asymptote. It tells me that when N is greater than D, I don't have a horizontal asymptote. Because of the fact that N is greater than D. Alright, let's graph it. No holes. I have x-intercepts at -3 and +3. I have a y-intercept at -4.5. I have a vertical asymptote at x equals -2. And there's no horizontal asymptote. So how do I do this? Well, it looks like, looking at these 2 points right here, the x-intercept on the positive side and the y-intercept, it looks like it would be a straight line. You could think about maybe a straight line in between there, but then you would say, no, that's not possible. Because this, from down here, it's going to have to go down here and bend and never touch that vertical asymptote. Never. That's telling me that this is probably going to go through here, hit that x-intercept, and maybe keep that same bend like that. And then I go back and think, oh, remember my symmetry between that imaginary vertical line thing there. Or, sorry, not vertical line, diagonal line. Through this imaginary line I'm drawing. It's not on the graph. But if that's the case, then maybe this piece looks like that. And that'll give me that symmetry. But you've been doing that. You've been working these on the homework and the review, and you've been checking yourself in the calculator, and you've been building these connections yourself. And that's how number 3 works. Alright, let's look quickly at number 4. Okay, factor the top and the bottom if possible. You should be able to roll right through these now. Y equals, top is difference of squares, that's x plus 4, x minus 4. The bottom is difference of squares, that's 2 plus x and 2 minus x. A lot of people want to write this as x plus 2, x minus 2. That's not true. You have to write the first term first. So the square root of 4 is 2. That's why the 2 comes first, because the 4 was first. Okay? Alright, nothing cancels, no holes. Straight into the x-intercept. Find the x-intercept. Set the numerator equal to 0. X plus 4, x minus 4 equals 0. So x is going to be equal to plus or minus 4 when I set each one of those equal to 0 and solve for x. So my x-intercepts are plus minus 4. Y-intercept. Solve for y after you plug in a 0 for x. So I've got y equals 0 plus 4, 0 minus 4, over 2 plus 0, 2 minus 0. And I simplify and I get 0 plus 4 is 4 times 0 minus 4 is minus 4 or negative 4 over 2 plus 0 is 2, 2 minus 0 is 2. Continuing on, 4 times negative 4 is negative 16, and 2 times 2 is positive 4, and I get that my y-intercept is negative 4. Vertical asymptote. Set the denominator equal to 0. So I have 2 plus x plus x, 2 minus x equals 0. So I have 2 plus x equals 0, 2 minus x equals 0. Here I'm going to subtract 2 from each side and get that x is equal to negative 2. Here I'm going to leave that 2 where it's at, and I'm going to add x to each side because that x is negative there. And if I add x to each side, I get that 2 is equal to x, or in other words, x is equal to 2. So x, in this case, is equal to plus or minus 2. So my vertical asymptotes are the vertical lines, x equals plus minus 2. Got 2 of them. Horizontal asymptote, got to find A, N, B, and D. A is, nothing canceled, so I'm going to go back to here. It's easier for me. I can see that the powers are 2. Okay? So A is 1 on top because it's the number in front of x on top. N, the power of x on top, is 2. B, the number in front of x on bottom, is -1. Some of you are not seeing that. You need to see that. There's a minus sign in front of there, so that's -1. And then D, the number or the power of x on bottom is 2. In this case, N is equal to D. They're both 2. And when N is equal to D, note card 42 tells you that your horizontal asymptote is y is equal to A over B, which is 1 over -1, which is -1. So my horizontal asymptote is along y equals -1. Let's graph it. Have no holes. Have x-intercepts at -4, +4. I have a y-intercept at -4. I have 2 vertical asymptotes at plus and minus 2. Okay. I have a horizontal asymptote at y equals -1. And I'm ready to try to graph it. This one's a little different, but it's not that difficult. First of all, I know that my function goes through this point, and this point. I also know that the function will never cross these vertical asymptotes, and that they usually never cross this horizontal asymptote. So my guess would be that it's going to go like this, not crossing or touching the horizontal or the vertical. And it's going in this manner because this is the way they've been working. They've been hugging those asymptotes like that. And then I've got this one piece down here, and I'm thinking, well, what in the world is going on with here? I know it's never going to cross these 2 vertical asymptotes, and it usually doesn't ever cross this horizontal asymptote, so I'm going to guess maybe it looks like this, hugging both of those vertical asymptotes down there. Okay? Okay, so for the sake of time, because I don't want this podcast to run too long, I'm not going to work 5. Let's look at number 6. And number 6 will serve as our multiplication and division problem. Number 8 is a lot like a problem from our homework. And we'll do 9 and 10. And then we're going to wrap it up right there. Alright, number 6, we're multiplying and dividing. Okay, so what you have to remember, first of all, is we're going to factor. We're going to try to factor everything that we can. And we also have some division here. That means I need to keep this fraction and flip this fraction. You always flip the fraction right after you change the division sign to multiplication. Okay, so I'm going to rewrite it. It's going to be 3x squared minus 21x. This is a lot like the problem from the homework in number 3 on the quiz we took. Then I have x squared minus 49. So if I give you something like this on your test, I expect every person to get it right. Changing this sign to multiplication, flipping this fraction, x squared minus x on top, 6x to the third minus 9x squared on bottom, and then just copying the rest of it. Okay, so I'm going to begin by factoring. This top I can factor out of 3x. So I'll pull out a 3x and I'm left with x minus 7. The bottom here is a difference of squares. That's x plus 7 times x minus 7 times, here I can pull out an x. This is not the difference of squares because x at the end here is not a perfect square. So it's going to be x times x minus 1 over, down here I can pull out a GCF of 3x squared, and I'm left with 2x minus 3 times, up top, difference of squares, that's 2x plus 3, 2x minus 3. Here I can pull out a GCF, pull out a 3, and I get an x minus 1. And then times, these two are Mustang factoring. I need two numbers that add to -9 at the same time, add to -9 and multiply to 14. The signs are the same, they're both negative, so that's going to be an x minus 2 and an x minus 7. If you don't know how I did that, you Mustang factor where you look at A, B, and C. Over, we need two numbers that add to 6 and multiply to -16. That's going to be an x plus 8 and an x minus 2, because 8 plus -2 is 6 and 8 times -2 is -16. So I have everything factored. At this point, first look, doesn't matter if you look at cross reducing first or top to bottom reducing first, doesn't really matter. As a matter of fact, you can probably just get it done by looking at cross reducing first. I mean, you can get it done both ways. Let's just look at some top to bottom stuff first. If I look at this first fraction, I see that I have an x minus 7 on top and on bottom. They cancel. They're gone. Second fraction, I have an x up top and I have two x's on bottom, or an x times x. This x squared, if I wanted to, I could rewrite that as x times x. That's the same thing. And that might be easier for you to see. Let me change colors so I'm canceling my help. That might be easier for you to see that this x cancels with one of those x's on bottom. Now looking at this one, nothing cancels from top to bottom. And looking at this one, I have an x minus 2 and an x minus 2. They're gone. Now I'm going to look at cross reducing. Here I have a 3x on top. Over here I have a 3x on bottom. They're gone. Here I have a 2x minus 3 on bottom and a 2x minus 3 on top. They're gone. Here I have an x minus 1 on top and an x minus 1 on bottom. They're gone. And what's left? Let's just write down what we have left. Nothing here on top, nothing here on top. Here I have a 2x plus 3. I have also an x minus 7. Over, on bottom I have an x plus 7. I have a 3. And I have an x plus 8. Nothing else cancels from top to bottom. You're done right there. Okay, let's move on to, we're going to do 9 and 10. Let's take a look at number 9. Okay, I'm subtracting, and I don't have common denominators. So the first thing I must do is multiply my two denominators together to find that common denominator. So that gets me x times x minus 2. Now, since I multiplied this denominator by this denominator, I must multiply this top by this denominator. So I get an x plus 4 times x minus 2 minus, open up a set of parentheses because you have to distribute this minus sign to everything inside over here. I multiplied this denominator times this denominator, so I must multiply this top by this denominator. Now at this point, all I want to do, I'm going to leave the bottom in factored form in hopes of that maybe something might cancel out and look nice at the end. All I'm going to do is I'm going to FOIL or box these two. I'm going to distribute here, and then I'm going to combine like terms and try to factor again at the end. Let's see what happens. When I FOIL or box this, I'm not going to go through all the motions. If you don't know how to do the shortcut, you will box it or FOIL it. So we have x squared plus 2x minus 8. This became this. Now I'm going to distribute this x. So I have minus parentheses. X times x is x squared. X times 1 is plus x. Over x times x minus 2. Like I said, leaving the bottom factored. Now I have to distribute this minus 1. So I have x squared plus 2x minus 8, and then minus 1 times x is minus 1 times x squared is minus x squared. Minus 1 times x is minus x over x times x minus 2. Combine like terms up top. I have a plus x squared, I have a minus x squared. They cancel each other out. Then I have a 2x minus x. That's just x. Then I have plus 8. I'm sorry, minus 8. Forgot my minus sign. Minus 8 over x times x minus 2. Nothing else factors, nothing else cancels. We're done right there. And the last problem we're going to work is number 10. Okay, so again, no common denominator, so I have to multiply them together. So I have 2x times x plus 3. I multiply this denominator times this denominator, so I must multiply this top times this denominator. Plus, since this is a plus now, I don't have to worry about opening a set of parentheses over here. Okay? I multiply this denominator times this denominator, so now I have to multiply this top times this denominator. So it's going to be x plus 3 times x plus 5. In other words, what I'm doing here is denominator times denominator, then I'm multiplying this top times this denominator, and then I'm multiplying this top times this denominator. Okay? So simplifying, here I distribute 2x times 3x is 6x squared. 2x times minus 2 is minus 4x. Plus, I have to FOIL or box these, and when I do, I get x squared plus 8x plus 15 over, leaving the bottom in factored form, x plus 3 times 2x. Now I'm going to combine like terms. 6x squared plus x squared. That's 7x squared. I can cancel those. They're gone. Then I have my x's. I have minus 4x plus 8x. That's a plus 4x. They're gone. I can mark those out. Plus 4x. And then I have one constant left, which is plus 15 over 2x times x plus 3. We would need to check this top to see if it's factorable using Mustang factoring, which means you have to look at all the factors. I will tell you that this one is not factorable after you look at all the factors of 7 times 15, because you have, looking at that top, you have A is 7, B is 4, C is 15. It's a pretty lengthy process to find it. 7 times 15. Well, I know that 7 times 10 is 70, and I have 5 more 7s, and 5 times 7 is 35. So that tells me 35 and 70 is 105, so 7 times 15 is 105. And I have to look at all the factors of 105. I have 105 times 1. It's not divisible by 2 because it's odd. Is it divisible by 3? Yes. So 3 goes into 10 3 times. It's divisible by 3. 3 goes into 10 3 times with 1 left over, so that's 15. So 3 goes into 15 5 times, so that's 35. Is it divisible by 4? No. Is it divisible by 5? Yes. 5 goes into 10 2 times, and into 1 and into 5 once, so it's 21. Is it divisible by 6? No. 7? Yes. 7 goes into 10 one time, there's 3 left over, and that makes that 35, and 7 goes into 35 5 times, so 15 times 7. Is it divisible by 8? No. 9? Yes. It may be factored. Let's take a look. 9 goes into 10 one time. Oh, it's not divisible. I'm sorry. It's not divisible by 9. I don't know what I'm thinking. It's not divisible by 10, 11, 12, and back up to 15. So these are the only factors, the ones I have listed here. And if my signs are the same and they're both positive, which set adds to 4? And that's none of them. So it's not factorable up top. Nothing else is going to cancel. Can't do anything else with it. That's your final answer. You do have to check those trinomials to see if they're factorable, to see if something cancels, so you can reduce it to its simplest terms if something does factor. We've been reviewing for a few days. There's some more problems worked for you. You should be very well prepared for tomorrow's test.